Hello everyone. In this tutorial, we will understand the concept of timer and we will see what is timer. So, as we know what is timer, timer is a clock that controls the sequence of an event while counting in fixed intervals of time. So, timer is a clock that controls the sequence of an event while counting in fixed interval of time. So, basically we know a timer is used for producing precise time delay. So, the term a timer is used to provide time delay, or we can use timer to repeat or initiate an action after a known period of time. So first, for providing time delay in any operation, and second one is for repeating or initiating an action after a known period of time. Okay, so for example, we can say if we set up an alarm which triggers at a point of time or after a period of time. So that is also an example of a timer. Now, here for understanding timer concept in PLC, I am taking one simple example. Suppose I have one simple switch, okay, and I have one lamp. Now, as I told you, as you turn on your switch, your output will be turned on. So what you will do? Just you will connect your switch with your lamp and you will give power supply. Okay, whether it is DC or AC. That's it. Now, if I say to you that you have to provide time delay in that operation, means as I turn on that switch, after 5 seconds, this light will be turned on. So for that, what you can do? Either you will go for a time delay relay. Okay, so this is the very simple example. Likewise, in industries, we have to connect many time relays if we follow this process. So instead of going this, in PLCs, we have internal timers, means there is no need to connect hardware timers with inputs and outputs. Just we have to use timers in our programs. Okay, so we can use timers in ladder logic programs. Okay, so now in ladder logic programs we have different types of timers. So first we will say based on redundancy, based on how your timer is holding accumulator value. So I will take timer. In timer we have two types. First one is retentive timer and second one is your non-retentive timer. Now, before understanding retentive timer and non-retentive timer, let's see some terms, that is preset value, or in some cases it is known as set value also. So what is preset value? Preset value is the value that we have to provide for timer instruction in order to provide time delay. Okay, and time delay we know means how much of delay you want in your operation. So for providing that time delay, we have to provide preset value, that is set value. Okay, and second thing that we have is our accumulator. Okay, so that name may be different in different manufacturers PLCs, but the common criteria, the common concept will be same. Second one we have as accumulator. So in accumulator means actual value, okay, or you can say counting value, okay, means how much of time is passed, okay, that you can say. Okay, so preset value will be a fixed value that will be provided by the programmer, and accumulator value will be counted according to the logics. Okay, so we will understand later. We have two timers, retentive and non-retentive. So retentive timer is that timer if enable switch of timer means in retentive timer, if enable switch of timer is in high state, once it will start. Okay, means suppose I am taking one enable switch and here I am taking one timer. Okay, so here I am putting general timer. Okay, now if this enable switch is in high state, means supply is coming towards timer, that means your timer will start. Okay, and your accumulator will start running. Okay, now accumulator can run in incrementing manner also or decrementing manner also. Okay, so your accumulator is running, okay, and it will run until it is reached up to preset value. Okay, so basically what is retentive timer? If that enable switch, okay, once your timer is activated, if that enable switch will go in low state, okay, means supply is not coming to this, what will happen? Your accumulator will stop and hold the last value. Suppose here we have provided 100-second time delay. Okay, now as I enable that switch, your accumulator will run 1 second, 2 second, 3 second. Now at 3 second I disable that switch, so your accumulator hold this value. Okay, now again when this switch is enabled, your accumulator will start running from 4 second, 5 second, 6 second, 7 second, means your accumulator is retaining its value. Okay, now again at 7 I close that switch, again your accumulator will hold 7 and your accumulator will start running again if your switch is in enable state. Okay, and it will run until accumulator equals to preset value, that is retentive timer. Okay, now second timer that we have is non-retentive timer. Now in non-retentive timer, as name indicates, it won't retain its value. Okay, means if enable switch of timer is in zero state, okay, or as you can see off state, okay, I am talking about NO switches, okay, off state, your timer will be reset. Reset means its accumulator will be reset. For example, suppose we have one NO switch here and here we have one timer. Now if I enable that switch, okay, that supply will reach up to this point, and this timer, suppose time delay here also we have provided as 100 seconds, that is our preset value, and now accumulator will start running from 0, 1, 2, 3, continuously it will run. As I turn off that switch, okay, as I turn off that switch, now what will happen, your accumulator will not hold its last value, that is 3, means it will reset or the accumulator will go to 0. Now if again I turn on that switch or I make it enable, what will happen, your accumulator will start running again from 0, 1, 2, 3, 4, 5, 6 up to so on. And whenever your enable switch is in off state, your accumulator will reset to 0, that is non-retentive timer, okay. So based on the holding of value, we have two types, retentive and non-retentive, okay. Now based on time delay, means based on delay, first one that we have is on delay timer, and second one that we have is your off delay timer, okay. Now understand this by that example. Here I have one switch, okay, now I have one lamp. Now I told you, when I turn on this switch, after 5 seconds your output will glow. So as you can see here, I have given supply to my output, but still my output is not glowing. So I am providing delay in turning on that output, that is on delay timer, okay. So as you can see here, I have input here and I have output here, okay. Now input take as timer here, okay, TIMER. Now your timer is getting pulse, means it is in on state, okay, but your output is in off state. After some time delay it is getting on, okay, and it is continuously on, okay, your timer is on. So here that is the time delay which we are providing for turning on at output, that is known as preset value, as I already told you, okay. So it is on delay timer. And second one, if I say same switch, okay, and same output, now if I turn on that switch, okay, my output will turn on same time, but as I turn off switch, my output will turn off after 5 seconds. So as you can see here, we are providing time delay for turning off an output that is our off delay timer. Okay, so if you see pulse, as input is on, okay, you can see input is high, output is also high, and it is continuously high. Okay, now as you can see, as I turn off input, output will turn off after 5 seconds. So that is the off delay timer. So as you can see, we are providing delay for turning off a timer. That will be over 5 seconds. Okay, or any other time delay. Okay, that is on delay timer and off delay timer. Now third criteria for defining timer that we have is based on accuracy. Okay, now based on accuracy we have three timers: regular timer, second one is high speed timer, and third one you can say is special timer. Okay, now accuracy is like that. In regular timer, that name will be different in different PLCs, okay, but concept will be same. So regular timer you can provide, suppose I will take example 5 second time delay I have to provide, I can provide by this. Okay, now I have to provide 5.4 time second delay. Okay, I can provide by that, but I have to provide 5.45 second time delay, so I am not able to provide by this timer. For that I have to go to high speed timer, I can provide through here. Okay, now if I have to provide 5.453 second time delay, I cannot provide by this timer. I will be able to provide this timer by this special timer. So as you can see, accuracy is increasing as we are going downside. So that is the based on accuracy that we will see later. So that is the timer and different time of timer. Okay.